Hi everyone, this is Cindy, and here today we're going to be working on homework journal question for section 3.1 altogether. Here's the statement that given the function f(x) equals to negative 2x to the power of 2, find the difference quotient f of x plus h minus f of x over h. And then we're going to be looking for f derivative of x by determining limit h going towards 0 of x f of x plus h minus f of x over h. And then we're going to find the derivative of negative 2 and f derivative of 0 and also 1. And lastly, we'll be graphing the function along with the tangent line. Firstly, we'll be figuring out the difference quotient through the derivative function. So firstly, as we know that our given function is f of x, f of x equals to negative 2x squared. So firstly, we're going to be following the function as f of x plus h minus f of x over h. So it's quite simple. So in the first term, instead of x, we'll be substituting x plus h. We're going to be substituting x plus h into the x. And then for the second term, it's going to be remaining the same. For the bottom, it's just going to be h. Alright, let's go and work on it. Firstly, we're going to rewrite the constants. So instead of x, we're going to be using x plus h squared minus negative 2x squared, because the second term is going to be the same. Alright, and then over h. Next, we're going to be solving and simplifying the terms. First, as we know that following along with the factorization rule, a plus b squared is going to be simplified as a squared plus 2ab plus b squared. So this is what we are going to be doing. So as x plus h, so x could refer as a and h could refer as b. So in this case, it's going to be x squared plus 2xh plus h squared. So we can substitute this into our term. So it's going to be x squared plus 2xh plus h squared. And then over here, it's not simply just minus 2x squared. Because there's a sign change of minus and minus a negative, so the sign is going to be changed into a positive, which is going to be plus 2x squared over h. And then we're going to be distributing negative 2 to each term within the parentheses. So it's going to be negative 2x squared minus, remember, plus and minus, it's going to be a negative 4xh negative positive negative 2h squared plus 2x squared over h. And then we're going to be combining like terms. So first we could find negative 2x squared plus 2x squared equals to 0. Simple. And then what we left with is negative 4xh minus 2h squared over h. Since both terms are having h, so we're going to be taking out 1h as a common factor. So it's going to be negative 4x minus 2h over h. And then we could factor out h from both numerator and denominator. So finally, what we left with is negative 4x minus 2h. Alright, this is the portion answer for our first part, which is negative 4x minus 2h. Alright, next, we're going to find the derivative of x. Derivative function of x by determining limit of x going towards 0. Quite simple. So we're going to be using the function that we received or we've get as a result from our previous part, and we're just simply substituting h for 0. So it's going to be negative 4x minus 2h. But this time h is going to be 0, which the whole entire second term is going to be 0, which is negative 4x. So the answer for second portion is going to be negative 4x. Next, we're going to find f prime negative 2, f derivative of 0, f of 1. So, as we knew that we had our new function right here, f of derivative of f prime of x equals to negative 4x. So we're simply substituting the x values into the function. So negative 4 times negative 2 is 8. Negative 4 times 0 is 0. And 1 multiplied by negative 4 is negative 4. So these are the values that we received for the tangent line of the original function. These are the coordinates. As x value is negative 2, we get 8 for y, 0 for x, and 0 for y. And then lastly, 1 for x and negative 4 for y. So let's write down our answers. And then lastly, we're going to be graphing the function negative 2x squared and also draw the tangent lines with the coordinates that we found through this process. So it's quite simple. Let's draw the x and y axis right here. Remember to label the x and y when if you're going to draw them by hand. 2, 3, 4, 5, 6, 7. Okay, I need to go above a little bit because I'm out of space right here. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Negative 1, negative 2, negative 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Alright. So firstly, we're going to be drawing the original function, which is negative 2x squared. So by doing so, we can simply just looking for several values, for example, negative 1. So subtracting negative 1 is going to be negative 2. And then for 1, we're still going to be getting negative 2 because it is a parabola that is facing down because it's having like a negative 2 slope, which also there's a both y and x axis when x equals 0, y equals to 0 as well. So we can see from there and simply determining our parabola is going 1 by 2, so right here. Then we're just connecting the dots. So like when we're doing our homework, it would be more accurate. And then for our tangent line f prime of x, is we're going to be utilizing the coordinates that we received from our previous portion of the problem, which is 2, negative 2, 8, 0, 0, and also 1, negative 4. Actually, like to draw a line, you only need 2 coordinates, but in this case, we have 3. And so we can just label them all together. Let me see. Okay, label them all together. So 0, 0. And then 1, negative 4 right here. 1, negative 4, negative 2 is going to be a right here. And then we're just connecting the line. Make sure they're connecting to each other. So right here, this part is f prime of x, the tangent line, and this is f of x, the original function. Okay, thank you so much for listening, and hope everyone's having a good time. Ooh, so I made a little mistakes right here. This part. So it's going to be 1, negative 2, so it's going down like this. No wonder it's supposed to like connect at some point. But yeah, it's doing good, I think, right there. Okay. Yeah, thank you so much for listening.